Hello everyone, I hope all of you are doing good. Yes, this is basically the PYQ session of the quadratic equations. So, in this session, we will discuss some latest PYQ of jeemains, that is, all the question asked for the jeemains 2025. Yes, I will solve here one by one, and if you have any doubt or if you have any another method to solve this question easily, please let me know in the comment box. And yes, what is the next topic that you want video, please comment me. And thank you so much for giving all the laughs and support for all that sessions. Yeah, so the first question is, let alpha and beta be the roots of x square plus root 3x minus 16 equals to 0, and gamma delta be the roots of this equation. Yes, this equation. And Pn equals to alpha power n plus beta power n, and Qn equals to gamma power n plus delta n. Then what is the value of this expression? So by seeing the question, that the recurrence relation which is given, Pn equals to alpha power n plus beta power n, and Qn equals to gamma power n plus delta power n. So you can easily think that that question basically is a Newton's formula that will be solved by this formula. And in the previous sessions, we already discussed the concept of the Newton's formula. I request to everyone, please, before watch this session, please uh, uh, watch all the previous concept that I've discussed. Then all the question will be very much clear to all of you how I am solving. Okay, so let's come to the topic. So what is the given, the quadratic equation is x square root 3x minus 16 equals to 0. So what is its root? That is alpha and beta. Okay, and what is the relation is given? Pn equals to alpha power n plus beta power n. Then by Newton's formula I can write x square, that is Pn plus root 3 into P of n minus 1 minus 16 into P of n minus of 2, that is equals to 0. Okay, so please notice what we have asked to find, that is P25 plus root 3 P24 by 2 into P23. Okay, so as that is P25, that is the higher suffix, so here I am putting n equals to 25. So P25 plus root 3 into P of 24 minus 16 into P of 23, that is equals to 0. So P25 plus root 3 P24, that is equals to 16 P23. Okay, yeah. And what the next quadratic equation that is given, x square plus 3x minus 1, that is equals to 0. And what is given, that gamma and delta its root. And what is the recurrence relation? That is Qn equals to gamma power n plus delta power n. So let us the Newton formula, that is Qn plus 3 into Qn minus 1 minus Q of n minus 2, that is equals to 0. And here also we have asked to find this Q of 25 minus Q of 23 by Q of 24. So the high suffix, that is 25. So put n equals to 25. So Q of 25 plus 3 into Q of 24 minus Q of 23, that is equals to 0. So here it implies that we have to find the Q of 25 minus Q of 23. So Q of 25 minus Q of 23, so that is equals to minus of 3 into Q of 24. Now come to the expression, that is P25. Okay, I'm just giving the another color that will be much more clear to all of you. Okay, so P25 plus root 3 P24 divided by 2 into P of 23 plus Q25 minus Q23 divided by Q24. Okay, so let us put the value one by one. So what is the value of P25 plus root 3 P24? That is 16 P23 by 2 into P of 23 plus, and what is the value of Q25 minus Q20, that is minus of 3 into Q24 by Q of 24. So what is that? 8 minus 3, that is equals to 5. So what is our answer? That is 5. So yeah, and it is the question of JE Mains 2025 April. Okay. Yeah. Yes, this is the question number 2. So what is given, that is let Pn equals to alpha power n plus beta power n belongs to the natural number, and if P10 equals to 123, P9 76, P8 47 and P1 equals to 1 is given, then we have to find the quadratic equation whose root 1 by alpha and 1 by beta. Okay, so for example, let us assume let a x square plus bx plus c equals to 0 be the quadratic equation whose roots are alpha and beta. Okay, and Pn equals to alpha power n plus beta power n belongs to the natural number. So we have applied the Newton formula here. So a to Pn plus b Pn minus 1 plus c Pn minus 2, that is equals to 0. So let us what is given, that is P10 P9 P8 is given. Okay, so put n equals to 10 here, n equals to 10, then a P10 plus b P9 plus c into P8, that is equals to 0. Okay, so let us put the value one by one. A into 123 plus b into P9, that is 76, and paid value is 47. So c into 47, that is equals to 0. Okay, so this is one relation, that is okay, and P1 equals to 1. So P1 means alpha plus beta equals to 1. So sum of the roots, sorry, yes, alpha plus beta equals to 1 means sum of the roots, that is equals to 1. Okay, and what is that sum of the roots here? And this implies that minus of b by a, because this is the quadratic equation whose roots are alpha plus beta, and alpha plus beta is minus of b by a, so that is equals to 1. So here b equals to minus of a. So in this expression, if we put b equals to minus of a, then we are having minus of a means minus of b. Okay, so 47b plus c into 47, that is equals to 0. So this implies that b equals to c. Yes, and b equals to minus of a. So let us put here a into x square, b equals to minus of a means minus of ax. Let this be the equation number 1, and put in equation 1 ax square, b is minus of x plus c equals to b means minus of a. So a, that is equals to 0. So a is non-zero, so x square minus x minus 1, that is equals to 0. So this is the quadratic equation whose roots are alpha and beta. Okay, so I have to find, so here alpha plus beta equals to minus 1 means minus by, so that will be 1, and alpha beta equals to minus 1, and I have to find the quadratic equation whose roots are 1 by alpha and 1 by beta. So the required quadratic equation x square plus sum of roots 1 by alpha plus 1 by beta into x, sorry, this will be minus sum of the root minus sum of the root plus product of the roots, that is 1 by alpha into beta equals to 0. So x square minus alpha plus beta, that is minus of 1, and alpha beta product, that is minus of 1 into x minus of 1, so that is equals to 0. So x square minus x minus 1, that is equals to 0. So this is our answer. So option number C. So let's come to the next question. That is, if the set of all A belongs to R minus 1, for which the roots of this equation are positive and is in minus infinity comma minus alpha union of beta comma gamma, then what is the value of 2 alpha plus beta plus gamma? Okay, so here the range of A is given R minus 1, and what are the given quadratic equation? 1 minus A x square plus 2 into A minus 3x plus 9 equals to 0. So let us assume that roots of this quadratic equation, one is x and another is y. So what are given? That is positive, means x greater than 0 and y is also greater than 0. So from here it implies that the sum of the root, that is also greater than 0, and the product of the root, that is also greater than 0. Okay, so from this equation I can write the sum of the roots, that is minus of b by a. So minus of 2 into a minus 3, and what is a? That is 1 minus a, that is also greater than 0. So 2 into a minus 3 by a minus 1, that is less than 0. So now let us find the range of a from the Wevikar method and putting the numbers on the number line. So let us say that is 3, and let us keep this number, that is 1. So what is this? That is less than 0. So plus minus plus, what is the range of a that belongs to 1 comma 3. So this is one interval. Similarly, the next is that the product is greater than 0. Okay, so what is the product is, that is c by a. So 9 by 1 minus of a, that is greater than 0. So this implies that 9 by a minus 1, that is less than 0. So from here it implies that a that belongs to, since this is less than 0, so this is 1, so minus, and that is plus. Okay, so a belongs to minus infinity minus 1. Okay, and what is given? That the roots are positive, means the discriminant d, that is greater than equal to 0. That is another condition. Okay, yes, so this is the another range of a d that is greater than equal to 0. So d means b square minus 4ac. So 4 into a minus 3 whole square minus 4 into a, that is 1 minus a, into c, that is 9, that is greater than equal to 0. Okay, so this implies that 4 you take common, and it will go to the right side, then it will give 0, that is square minus 6a plus 9. Okay, so minus of 9 plus 9, that is greater than equal to 0. So this implies that a square plus 3a, that is greater than equal to 0. So this implies that a into a plus of 3, that is greater than equal to 0. So let this is minus of 3, and that is 0. So what is the range? That is plus minus plus. So the range of a is minus infinity minus of 3 union of 0 comma infinity. So we have the 3 range of a, and with this 3 range we can take the common. Okay, so let us put that is minus infinity, then that is plus infinity, let that is 1, then it will be 3, and let that is minus of 3. Okay, yes, so in the first one a is in 1 comma 3, so a is in interval, in this interval, and then in the second one a is minus infinity minus 1. So let this minus 1, so a is in minus infinity minus 1. Okay, and in the next one a is minus infinity minus 3, so a is minus infinity minus 3 is this, and 0 comma infinity. So let this be 0, and that is 0 comma infinity. So what is the common? A that belongs to minus infinity minus of 3 union of, and this one is common, so 0 comma 1. Okay, this will be open. 0 comma 1. So, and what is given? A belongs to minus infinity minus alpha. So from here alpha equals to 3, comparing this given condition, and beta equals to 0, and gamma equals to 1. So what is asked to be find? That is 2 alpha plus beta plus gamma. So 2 alpha plus beta plus gamma, that is equals to 2 into 3 plus 0 plus 1, so 7. So this is our correct answer. This is the next question. Have a look. Consider this equation: x square plus 4x minus 9 equals to 0, where n is the natural number that belongs to the closed interval 20, 100, and this is given that the number of all distinct values of n. Okay, we have to find the number of distinct values of n for which the given equation has a integral root. So what is the equation is given? X square plus 4x minus 9 equals to 0. Okay, so what are the roots of this equation? Minus 4 plus minus root over of b square minus 4ac. b square means 16 minus 4 into a is 1 and c is minus of 9 by 2 into 1. So that is equals to minus 4 plus minus root over of 16 plus 4n by 2. Okay, so that will be minus of 2 plus minus. So if we take 4 as a common, so 4 will comes out as 2, so 2 gets cancelled out, so 4 plus n. So here you can see that that will be means this is an integer. So when this will be integer, it implies that this is an integer. Okay, so since this is an integer, so root over of 4 plus n is a perfect square. Okay, perfect square. Okay, so what is the n belongs to 20, 100. So from here n plus 4, that also belongs to 24, 104. So what will be the value of n plus 4 in this interval for which that will be the perfect square? So n plus 4 can be 25, then 36, then 49, then 64, then 81, then 100. Okay, so what will be the value of n? 21, 32, 45, 60, 70, 77, and 96. So the number of values of n in this interval, that is 1, 2, 3, 4, 5, 6. 6. So 6 is the correct answer. Yeah, so today up to this, there are so many questions left. So we'll do in the next classes. So thank you so much, and please comment me if you have any doubt, and also let me know in which next topic we'll make the video. Okay, thank you so much.